to start for 8-4 day 2 today, I want you guys to go ahead and find these 3 problems in your binder, and I want you to go ahead and solve for them. The first 2 are the easier law of cosines to solve. The third one is the tougher one. It's where you solve for an angle. You're still going to use the same equation, but what I want you guys to test here is for these 3 problems, can you get, for the first one, x to be about 5.9? For the second one, can you get x to be about 42.3? And for the third one, can you get x to be about 78.6? And this one's a degree. Just in case anybody is kind of struggling to get to this point here, the step before the 5.9 should be that right there. Just a couple reminders here as far as the formula. If you look at the law of cosines formula on page 370, they actually give you 3 different formulas, and the only thing they do is they switch the A, the B, and the C around 3 different times. What I like to do is, instead of looking at 3 different formulas, I like to just use the top one, and whatever one I know the angle and the side opposite from, those are my A's automatically, and then I just have to use one formula. Now, one thing to think about as we get ready for our study guide and our test, if you go to fill in your capital A, your lowercase a, your lowercase b, and your lowercase c, and you find that you don't know more than one of those letters, then you cannot use the law of cosines, and you need to be looking at the law of sines or SOHCAHTOA. So I can only have one unknown out of these 4 letters, okay? Now, number 2, the step before the final step, you should be getting x squared to be about 1792. And once you square root, that's where the 42.3 comes from. Down here for the tougher one, one thing you can do a little bit more simplifying with is you could maybe get your simplifying to look like this. And then when you go to 0 out and when you go to 1 out, right before your last step, this is what you should get. So that's when you're going to inverse your cosine. And when you inverse your cosine here, that is where you get the 78.6. Okay, so again, what you need to understand about 8-4 day 2, the law of cosines, it's the same formula as yesterday. Now it's just going to be a little more word problems. So what they're asking us for here is basically the distance the golfer has to hit the ball in order to get it into the pin there, okay? So that we are going to call A, lowercase a, which means its partner angle is capital A, the 13 degrees. That also means that one of these sides that are left over are B and C. Remember, B and C are replaceable with each other. Doesn't matter which one's which. All right, so what we have here is we have A squared equals 300 squared plus 275 squared minus 2 times 300 times 275 times the cosine of 13. This is the one on the right side. If you can get it all entered into your calculator, you're going to find that A squared equals 4853.9393. So again, the reason why I'm using 4 decimal places is because that's not my final answer yet. Anytime you solve for a side in law of cosines, your last one is to square root it, and that is where we are going to round our answer more than likely to the nearest tenth. So the distance there of A is about 69.7 yards. I invite you guys to try this. Type it in your calculator. Make sure you can get it. If you can't get it, you have questions, so then just bring those up. I want you guys to go ahead now and flip over to the back, and I want you to do practice 4 first. So we're going to go in reverse order of the practices. Do practice number 4 first, and then we'll come back to the other practice problem. Really, the only difference from yesterday's lesson is now there's kind of like a follow-up question. So if you guys notice, the first ranger station is 2.1 miles away from the Bald Mountain. What they're thinking about doing is moving the ranger station to Fire Tower, but the only way they're going to move the station to Fire Tower is if it's closer to Bald Mountain. So more than likely, that's where a lot of the fires are happening. And so because this distance here ends up being about 1.6 miles, it would be closer to put the ranger station there, and that's why I have a yes. So you can just double check that you got the numbers in the right spot. Again, when you're solving for a side length, you can type this whole thing in your calculator as long as it doesn't mess you up. Couple things though, these are built-in squareds. This is a built-in plus, built-in minus sign. These are time signs. And then this is always cosine. This is the law of cosines. Okay, so this example is a good one because it's going to use law of cosines from 8.4, and then it's going to go back to section 8.2 and review our SOHCAHTOA. So again, just a reminder, 8.2 was SOHCAHTOA. You had to have a right triangle, but it was the easiest of all of them. 8.3 was the law of sines. We no longer have to have a right triangle. Little bit easier formula, and then 8.4 was the law of cosines. All of them are fairly easy. It's just a matter of the amount of work you have to put into solving them. So the surface ships in the figure have determined the indicated distances. They want us to use the law of cosines to find angle A. So we're going to go ahead and use our vantage point of A there. So that automatically means that 629 is our lowercase a, and then 615 and 499 are our B and C. Again, those two can be switched around if we want to. Now, I told you guys that I would show you a little bit of a way to simplify this. So we're going to do A squared equals B squared plus C squared minus 2 times B times C times the cosine of A. And the fact that this variable is on the right side makes everything a little bit tougher for us. Now, one way you can kind of simplify your steps and not make them so many is by taking and squaring this number here. And then in your calculator, you can do this part right here all together. So then we end up with 627,226. And then in our calculator, we can do that part right there. So 613,770 times the cosine of A. So that'll shorten it a little bit. But again, remember, we cannot combine these two because of where our variable is. So now we're at a point where we're going to zero out, we're going to 1 out, and then we're going to do our final step. So when we zero out, we're going to zero out this number right here. So we're going to zero that out. And we get, yep, we get a negative number. Remember, this minus sign right here now is a negative in this number. It needs to be there. That's going to throw everything off. So we've zeroed out. Now we're going to go ahead and 1 out. That's going to make everything into a positive now. Again, I'm going to write this to 3 decimal places just to make it a little more accurate. And just like with the law of sines, with SOHCAHTOA, when we have to inverse or get rid of sine, cosine, or tangent, We're going to use our inverse or our arc cosine here. And that is going to give us the measure of angle A to be about 67.8 degrees. What you need to understand is we could do law of cosines again to solve for this next part. But why do that when it's so much longer, okay? SOHCAHTOA is that much more efficient. It's quicker. So what we're going to do here is we see that we have a right triangle. So we have a right triangle in which we now know the angle. So that is the triangle I'm going to use. We know my angle is 67.8. We know we're solving for x, and we know our hypotenuse is 499. Like I said, when we first learned SOHCAHTOA, we were kind of shocked by the sine, cosine, tangent that was out there even. So I don't know if we really was effective enough on SOHCAHTOA. Remember that whatever angle you're standing at, that is going to tell you your locations. The hypotenuse is always opposite of the right angle. The other next door side is always the adjacent side. And the side opposite of that is always the opposite. Now, for what we want to solve for, again, just like in law of sines, just like in law of cosines, we can only have one unknown. So we can't use the adjacent side because we don't know anything about it. So from this vantage point, we're going to use opposite and we're going to use hypotenuse. So because of opposite and hypotenuse, that is the sine. So the sine of the angle always equals the opposite over the hypotenuse. So now to solve this, we have to get rid of dividing by 499 and multiply by 499. So now we're able to just type this in the calculator, and we end up with x being about 426 feet. Okay, I want you to try one more practice problem. It's actually the first practice problem on the back. You are just practicing finding the angle. You're not going to do anything with SOHCAHTOA on that one. So go ahead and flip to practice number 3 and try that one. All right, so you guys need to double check that you can get the 59.7. Just like I said, the only difference from day 1 to day 2 is they kind of have a follow-up question. So what you need to understand about a solar panel is it works better if it receives more sunlight. So if the rays are shining directly on it, it's going to have more power for you. So what they found here is that if the solar panel is between 58 and 60 degrees at that angle, it's receiving more sunlight rays shining down on here. So that's why we wanted to do angle P, to make sure that it is receiving the sunlight it needs. So because it's at about 59.7 degrees and because it's between 58 and 60, that means the amount of rays that's hitting it is creating more power.